Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on December 1st, 2025, about a week ago. It introduces an architecture that finally lets smart contracts securely control cryptographic private keys, using a pull-based authorization check called Hot Verify, together with a threshold multi-party computation network, so contracts can sign messages and act across many different blockchains. The paper is titled Hot Protocol, and as we will see later, the design has big implications for cross-chain wallets, safer key management, and more flexible decentralized applications. Alright, the introduction laid out the core idea in words, and Figure 1 now turns it into a simple flow. The third party first sends a signing request to the multi-party computation network, which holds the split private key. The multi-party computation network then queries the key owner contract using Hot Verify to check whether the message is allowed. If the contract authorizes it, the multi-party computation network returns a valid signature back to the third party, so the contract effectively controls the key without ever storing it. So, Figure 2 shifts from the message flow to how keys are registered in the first place. Figure 2 shows that the key owner contract sends its chain identifier and contract address into the key registry, which records who controls each key. The multi-party computation network separately sends a key identifier into the same registry. The merging step in the middle means anyone can later look up a key identifier and discover the correct controlling contract. Alright, the previous figure described how keys get registered, and Figure 3 now explains how the multi-party computation network comes online. The Genesis deploys step first creates the multi-party computation controller contract on-chain, which acts as the coordination hub. Node 1 then connects through its blockchain client to register with that controller. Inside Node 1, the crypto module handles threshold key duties, while the final arrow shows Node 1 informing the remaining nodes, so the full multi-party computation network initializes. So while Figure 3 showed how a single node joins, this figure lines up the full request path through the system. A third party first sends a request through the gatekeeper network, which forwards it into the multi-party computation network. Inside that network, Node 1 runs a crypto module alongside a blockchain client that talks to three contracts: the multi-party computation controller, the key registry, and the key owner contract. Additional nodes join via step 6, so threshold signing can happen collaboratively. Well, the previous figure focused on the technical request path, and Table 1 switches to the economic roles around it. Table 1 lists 5 roles, and whether each must stake or can earn the governance token, plus the type of contribution they make. DAO members and multi-party computation nodes both stake and earn, because they provide governance and hardware. Gatekeepers only stake for secure request distribution, while fishermen only earn for monitoring, and regular users neither stake nor earn, since they are just smart contract users. So, two big takeaways stand out. Hot Protocol lets smart contracts actually control cryptographic keys through a pull-based authorization check, plus a threshold multi-party computation network, and it turns that into a cross-chain, hardware-backed security layer with real economic incentives. That unlocks safer wallets and richer decentralized apps. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.